like to start with this warm-up, and I'd like you to evaluate each of these without a calculator. So press pause on your video, and when you're ready for the answer, press play again. So you should have noticed as you looked across here that each of these was 0. Log base 3 of 1 is 0, log base 7 of 1 is 0, and log base 10 of 1 is 0. That's because the exponent that goes on each of these bases that causes my value to be 1 is 0. So in this case, 3 to the 0 is 1. Remember, a log is an exponent. It's the exponent that needs to go on this base in order to get the argument. If I look at the second case, 7 to the 0 is 1. That's why that's 0. 10 to the 0 is 1. I hope you're noticing a pattern. We're going to generalize a property in a few minutes. And this row, 3 to the log base 3 of 81 is 81. Why is that? Because I know that 3 goes to the log base 3 of 81. So I'm asking myself, 3 to what power is 81? And that would be 4. 3 to the 4th is 81. Okay, so now this goes on the 3. Therefore, my answer is 81. Looking here, I didn't have to write base 10. I guess I was being pretty nice. Log base 10 of 100 is 2. So that means this is 10 squared, or 100. Log base 2 of 8 is 3. 2 to the 3rd is 8. Are you starting to notice a pattern? If I have a base and it's raised to a log of the same base, they undo each other and I just get the argument out. Argument, argument. So here are two properties that we should be able to see just by doing that warm-up. A log with any base of 1 is equal to 0. And the other one is if I have a base, A, and I raise it to the log of a same base, and the argument's x, I get x out. Now it's going to be important to know all the properties, and these are ones that you should have memorized or can figure out quickly. So today we're going to look at properties of logarithms and their graphs. We're going to be talking about the domains of our graphs. And we are going to look at a few more properties than the ones we just discovered in our warm-up. I'd like you to evaluate each of these expressions, and then I want you to see if you can't generalize a property from what you discover here. Press pause on your video. When you're ready to look further, press play again. Okay, let's look at the first one. This says log base 2 of 2 to the 3rd. Okay, well that is log base 2 of 8. And then I have to ask myself, what power do I need to put on the 2 in order to get 8? Well, that is 3. The next one says log base 4 of 4 to the 5th. Well, look at this. I'm not going to figure out what 4 to the 5th is because this log says, what exponent do I need to put on a 4 in order to get 4 to the 5th? Well, clearly that's 5. Looking at the next one, log base 5 of 5 squared, this says, what exponent do I need to put on a 5 in order to get 5 squared? And that would be 2. So, looking at that, I should know that log base A of A to the x is equal to x every single time. Here's another property. If I have two logs of the same base set equal to each other, then I know the arguments have to be equal. So if log base x equal log base 10 of x equals log base 10 of 2, then I know x has to equal 2. So let's review these properties. Log base a of 1, any base, when the argument is 1, gives you a 0. That's because any base raised to the 0 power is 1. Log base a of a is 1. That's because a to the first power is always a. Log base a of a to the x is x, and a to the log base a of x is x. Logs and exponential functions undo each other. They are inverses of each other. And then finally, if I have two logs of the same base set equal to each other, I know their arguments must be equal. Make sure that you have all these properties written down in a safe place. They are all ones that you need to know quite well. Okay, keeping those properties in mind, I'd like you to evaluate each of these without a calculator. Press pause on your video, and when you're ready for the answer, press play again. Here are my answers. Log base 3 of 1/9 is -2. That's because 3 to the -2 power equals 1 over 3 squared, or 1/9. Remember, the next one, this is a crazy base here. But remember, log with any base of 1 is 0. That's because any base I have, I raise it to the 0 power, I get 1. This next one, ln of the cube root of e. Remember, ln is log base e. So this is log base e of e to the 1/3 power. Remember, the cube root can be written with a fractional exponent. So using our property that says log base e of e to the 1/3, I get 1/3. Looking at this, what exponent do I need to put on e in order to get e to the 3rd? That's 1/3. This next one's undefined. There is no power to which I can raise 10 and get 0. It's undefined. This next one is 3/2. The way you find that is you have to rewrite 5 square root of 5. It's 5 to the first times 5 to the 1/2. Remember that when you have like bases, you add exponents. It's 5 to the 3/2. And now I'm looking at log base 5 of 5 to the 3/2. Using our property that says log base 5 of 5 to a power, these undo each other, I get 3/2. And my next one is -2, and that is because 1 over 25 is the same as 5 to the -2. Next, I would like to show you how to find the domain and the x-intercept of a logarithmic function. So remember that this argument must be greater than 0. So to find the domain, I just take my argument. I say it has to be greater than 0. So I see that this is x has to be greater than 4. So my domain is 4 to infinity. To find the x-intercept, remember the x-intercept has a y value of 0. Anywhere on the x-axis, y is 0. So I take my logarithmic function and I set it equal to 0. I can rewrite this in exponential form. So I know that 0 is the exponent that I need to put on the 4 in order to get x minus 4. So 4 to the 0 has to equal x minus 4. Well, 4 to the 0 is 1. So now I simply add 4 to both sides. X is 5. So my x-intercept is 5, 0. So again, this is common with any function. If I want to know the x-intercept, I make y 0 and I solve for x. The key here is that you have to take this logarithmic function and rewrite it in exponential form to get rid of the logs. Right now this says base b. I would like for you to make it a base of 3, and I want you to find the domain of the function, and while you're at it, also find the x-intercept. Press pause on your video when you're ready for the answer. Press play again. Here are my answers. My domain is negative infinity to 5/2. My x-intercept is 2, 0. This is how I found it. I took my argument to find the domain. I know my argument has to be greater than 0. And I solved for x. I subtracted 5 from both sides. Then I divided both sides by -2. And when I did that, I remembered to flip my inequality sign. And that's what my domain is. To find my x-intercept, I set my function equal to 0. I solved for my log. I rewrote my log in exponential form. 3 to the 0 is equal to 5 minus 2x. Solve for x. I find x is 2. My x-intercept is 2, 0. Next, I posted some practice for you online. I'd like you to work on that. Whatever you do not finish as homework. Have a great day.